Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today, the question that I'm pondering is, should we write one assertion per test? And this started from a conversation on Twitter with Matthias Ferraes, and I'm gonna go into the details of this in a minute. Before that, let me tell you just that I missed doing these things. For 2 weeks I've been out. My voice was broken. I couldn't actually speak due to a cold, basically a seasonal virus. Also, we had a bunch of issues with the latest video I published, and I plan to re-record that. The sound was lost after a few minutes. So anyway, we'll get back to it. I hope you are ready for more interesting conversations. Let's get back to the question, should we write a single assertion per test? And this started from this tweet by Matthias Ferraes. One assertion per test is the sort of thing you teach TDD beginners as a crutch, but it's not a good universal rule. You should test one concept per test, one rule, one unit of behavior. Sometimes that concept is better expressed with more than one assertion. And I agree in principle, but I have some observations, and this is where this all started. I think that one assertion per test is a good rule in general, because if you have one assertion per test, it's more likely that you are testing a single concept or a single rule or a single unit of thing, right, of behavior. However, I think it's been misconstrued by meaning that we only need to use the asserts that are provided by the unit testing library or by the assertion library that we are using. And to me, that's not correct, because what you can do is build on top of the existing asserts and write what is known as a custom assert. The custom assert is an assert that talks about the domain. Let me give you an example. If we imagine you are developing a Tetris game, right? So in a Tetris game, you have falling blocks of different shapes. You might have an L, you might have a reverse L, you might have a square, basically an O, you might have an I, and so on. So there are various shapes. And one thing you could do is to say, let's create a shape and then assert that this shape is one of the valid shapes, right? And you can write this as multiple asserts and say, assert, this is one of either an I, an L, an O, and so on. Or you can say, assert this shape is one of something, one of the ILO shapes. And if you write a single assertion, a custom assert, this raises the abstraction level to the level of the domain of the problem. So instead of saying things like, assert this block has 4 squares and the squares are one near to the other, you would say things like assert shape is an I, assert shape is an L, and so on. So you can do things like that, and you can do things like that also if you take a business application. Let's say you have a user, and a valid user needs to have an email address. And when you create a new user, you want to check that it has a valid email address. One thing you could do is to say assert user is valid. And that would include perhaps multiple asserts, one that would check, I don't know, that the user has a name or a first name and a last name, that it has an email address, and so on. So I believe that this raises the level of abstractions in tests, and what you are actually doing is you are designing tests. And this is a very powerful concept. I think a lot of our tests, a lot of the tests that I've seen are under-designed. And they suffer from a form of primitive obsession in which we're basically using the primitive asserts instead of building on top of those and creating language that is valid for the tests. So this is my stance, my general stance on this, but then the conversation got into more interesting places, and I'm curious to read through the answers. So my answer was, I agree in principle with one addition. I usually, but not always, extract those into a custom assert that better expresses the domain constraint. So there's value in thinking about a possible name for multiple asserts in a test without making it a strong rule. And this is important. You don't... If I need to write a second assert, I will just write a second assert. But after 2 or 3 tests, I often see that we have asserts that repeat. And then it's just a matter of removing duplication. So then you extract the duplicated code into a custom assert. You give it a name, and then name becomes the thing that you are checking for. And now it's interesting because sometimes you'd have different asserts duplicated in different contexts. And when you have different asserts like this, you might end up with multiple custom asserts. So then the next question would be, do we need to separate tests so they only have one custom assert? And the answer to this is, it depends. It depends on how you expect the object to change. Because remember, one of the reasons we are doing this is to have a decoupling between the test code and the production code. We want, when the production code changes, to only change the minimum amount of test code that we need to. And this is a general principle that's really good. It's a really good idea. Once again, I see too many test suites that are heavily coupled with the production code. And then people change the production code and complain that they need to change a lot in the tests. Of course you do. You need to think about how to separate the production code from the test code, how to have this decoupling. And one of the ways is to figure out what are the things that are constant, and what are the things that will change together, and what are the things that will change separately. Basically, like in any other part of the design. And only in tests it's a bit more different, in the sense that you need to have, you have a limited number of design elements that you can use. You can use custom asserts, you can separate tests, you can use data-driven tests, which basically mean you extract, if you have duplication between multiple tests, but the only change is the data in and data out, you can extract the skeleton of the test and use a data-driven test to go a number of times with different inputs and expecting different outputs through the same test. And then you have a number of building patterns that help you in case you have more complex data, more complex setups. If you have a complex set of input data, you might end up needing things like builders or data mothers, which are so builder, you probably know the pattern is when you can, usually it's with a fluent interface where you can build variations of the same object using a fluent interface, or variations on a graph of objects. And object mother is one where you have some set objects that you can start from and then modify, sometimes using a builder. So for example, in one of the products that I worked, it was a product for e-health, for general practitioners, for family doctors. And in that case, one of our object mothers was Dr. House, which was a doctor that had a person associated. The person was named Gregory House, and the doctor had some specialties and so on. And we could start from this doctor and modify a few things, or just use it as it is in our tests. So this is a good idea. And then Matthias's answer was, sure, but that's more a matter of general engineering practices than testing practices. It only makes sense if you're going to get a lot of reuse. And Jakub answered, readability is another factor. Readability is also general software engineering practice, said Matthias. And in both test and production codes, it requires a fine line between abstraction and being specific. And I agree, this is a very interesting conversation, but I think one thing that's very different between production code and test code is that you want the test code to be even simpler, more readable, shorter than production code. So if I could have tests that are 1 line long, or long as 3 lines long, maybe 5 lines long, but then every line is very expressive and it tells me exactly what is going on. It has precisely the right names, and I can read it as a scenario, as a story. Then that helps me a lot when dealing with large test suites. So I think readability is often more important for test code than for production code, which is why I think in the case of tests, duplication is not the first thing that I might look at. I might look at a single assert or 2 asserts that I don't understand. And there are a few things that I can do. I can extract the body of the assert, the actual condition, like user.name equals is not empty, I can extract this into a variable that says username is not empty, and at least I have a name for that condition. And then I might say assert username is not empty. It's good enough. But this introduces another line of code in my test, which I don't really like, which is why even if I see it only once, I might extract it in a custom assert that gives me a good name so that the test is more readable. And I think this is more valuable for test code than for production code. Because in test code, these things are easier to change. It's likely that I will add some additional conditions for a valid user, let's say, for a valid new constructed user. But it's not necessary that I will have the same level of readability and brevity in the production code. I think it's more important for tests. Right? And then Robert Smallshire interjected, for me, it also depends on the quality of the diagnostic message emitted when the assertion is not satisfied. This is another thing that's very important, and why it's so cool to have in TDD to see the test failing first. When I see the test failing first, not only I validate that the feature is not yet implemented, the behavior is not yet implemented in the production code, but I also validate the diagnostic message. And often I would spend some time on refining the diagnostic message displayed by a failing assert before I actually move forward and implement so go to the green phase, implement the simplest code that could possibly work, and then refactor. And because of this, sometimes I will see red multiple times for the same test, but that's okay, because the goal here, as I said, is twofold. One is to see the test is red, which is a good indicator that you are adding something new. The second is to see that the message, the diagnostic message, is actually very useful. And then Chris Carroll added, this seems to me more important than rules about test organization. But there is a widespread fashion of no diagnostic output, believing that the test name is informative enough for all your needs. No, so I don't think that's true. I do not think that's true. I think it's good to have a good name for the test, and when you name the test, it should describe the scenario. Too often I see test names that just say test users, but it doesn't tell me anything about what are they actually validating. So test newly created user is valid, right? So I'm missing the last part oftentimes, the last part being the condition that I'm checking for. A behavior, if you think about the behavior, since a unit test should check one behavior, the way you can think about the behavior is in terms of given, when, then. So given a newly created user, when I validate it, then it's valid. This would be a given, when, then statement. But to me, these are too long. I don't really like them. I like to have like a short sentence, usually with underscores or with camel case. And so the name of the test should include what you're checking. Because then when you see the test is failing, it's to say, okay, newly created user is valid. All right, so it's not valid because it failed. And then I see the assert message, which would tell me something like empty name, or user doesn't have a valid name, or username is empty. This would be a good diagnostic message. So all these things need to fit together. The name of the test and the diagnostic message. So I believe these together should be working fine. Now, there are some frameworks in which, some unit testing libraries in which it's a little bit more difficult to create custom asserts. It's a little more difficult to make the message better. But it's worth taking the time to figure out how to do it anyway, because it is possible. Only you sometimes need to understand a bit better how the assert library, the assertion library, typically that's where the problem lies, how the assertion library works and how you can write your custom assert in that assertion library. Then Robert answers, I used to care a lot about test naming, but then I realized that I just click on the fail test and read the test anyway. This is true, but um, there's also another thing here which would be really nice. Imagine you run the tests, they are all green, but they give you the list of behaviors that work in your system. And if you take the camel case or underscore names, you can actually generate sentences that say, okay, so we are checking users, usernames are valid, usernames are... This is really cool. And if we could do that, and I know there are some systems where you can actually generate some text from the name of the test and the asserts. This is really nice because this would give you basically the specification, the list of all behaviors that currently work. And those are useful when having conversations with non-technical people about what already works in the system and what doesn't. You can do this probably with things like Cucumber. If you start the other way around by writing the tests as text and then linking the text to code. But in this case, it should be possible to do it the other way around and generate reports from tests. It's not that hard to do. Unfortunately, the systems there are not so good. And then Matthias replied to me, writing and thinking and naming tests is the same. If I can find a good name, writing the test is pretty much an implementation detail. Your mileage may vary, of course. So, yeah, more or less. Sometimes I know the test name. Sometimes I kind of poke the system, so I write the test and try to figure out which would be the next one. And then I don't really know the test name, but I kind of figure it out in the process. So this depends. Yes, Bjorn Einar Bjarnes answered then. Yes, I have also been thinking something like, can't one logical assertion be multiple assert statements sometimes? Of course. To compete in the races, Matthias responds, it has to be a horse and it has to have 4 legs, or at least 4 legs. Okay. Right, and they do... the conversation moved into a fun territory, as it usually happens. Now I was thinking horse as opposed to donkey horse and zebra horse and the like. Said Einar host. Matthias answered, if I put a donkey in the back of the horse, it's a donkey. Horse implements horse. But if I put a horse on a donkey, it's a donkey. And I don't know if I can still rightfully implement horse. I kind of want to edit a 4th edition of Data and Reality now, shouldn't me? Horse and Matthias both implement shootable. All right. Let's move to Frederic Bonnet. Multiple assertions per test is okay. However, you should have only one act as in a range act assert per test for real atomicity. Oh, this is interesting. I haven't thought about this. And then Matthias answered, disagree. I may want to test the interplay between 2 actions. Frederic Bonnet answers, I'm specifically talking about atomic tests here, and that's the most common in TDD. For regular integration testing, you'll typically need more than one. So do I write tests that do multiple actions? I do sometimes, yes. Yeah, of course. So to me, that's not a quick and fast rule. I don't try to write only one line of act, basically. I do write multiple lines of act. Why would, and then Steve Bishop returning to single assertion, why would single responsibility principle not apply to test methods? Matthias, it's single responsibility, not single assertion. And Steve Bishop, more than one reason to fail sure seems like more than one responsibility. Matthias, I'm sure that's true in most cases, but one responsibility is about a unit of behavior, and sometimes a behavior needs to be tested by asserting multiple properties. Equating responsibility or reason to fail seems reductionist to me. Steve Bishop, SRP, single responsibility principle, is reductionist, that's the point of it. So, should we have only one reason to fail for a test? So let's think about this example. I think I'm more worried about multiple tests failing because of one thing. Because one thing that's really annoying is when you make a change in production, which you shouldn't do without changing the tests. Okay. But let's assume that you do it using TDD correctly. So you first change the test that fits that behavior. And then you change the code. But then after you change the code, you have 200 tests failing. Now this is a very annoying thing. So ideally, one change in production or one problem in production code should trigger a single test or at least a minimal number of tests. Not 30, not 200. If it's 3, if it's 5, fine. Even if it's 10. But if you have 30, 50, 200, 500, then it's something is wrong in the way you have organized your tests or in the way you have organized your production code. So this is the first priority to me. Trying to make sure that we minimize the number of tests that are failing when we change something in production. And how can we do that? Well, in order to do that, we need to separate the tests as much as possible and to remove duplication from the tests. That's one thing. The second thing is, what if you have multiple reasons to fail in a test, that is not as annoying, right? Because what might happen is your test will fail once, you'll change or fix the first assert, and then it will fail the second time, you'll fix the second assert, and so on. Or another thing that might happen is you run your test suite, you see, let's say, 5 tests failing, you go into one test, it has 5 asserts and it failed on the third assert. This is pretty easy to figure out, right? It's not as neat as having one single assert per test. So the single responsibility principle equivalating with a single reason to fail. But it's manageable. It's something that you can deal with pretty easily with most unit testing frameworks, because you'll know exactly where it failed, and if you wrote that assert in a nice way with the correct message, you'll know exactly why it failed. Is it as neat as having them separated? No. But is this a really hard and fast rule that you must follow? I don't think so. I would rather figure out and focus on figuring out how to avoid having 200 tests failing at once. Okay. And then Erkan Kozi, I think, jumped into the conversation. One unit of behavior. Unit is the most problematic concept. Better to stay away from unit. And then Matthias posted something, a longer tweet. And Erkan answered, unit is relative, a perspective at a single abstraction level. An isolated unit is not interesting at some point in its for system. A system is greater than the sum of the parts, aka system show behavior that does not exist in its parts, then fun stuff starts. I don't fully agree with this. This is just a matter of failing to do modular design or modular architecture. If you can separate modules, then each module can have its own behaviors. And then, okay, you have multiple behaviors in a module, whether they are distributed in one behavior could be in one class or it could be in 5 classes. Doesn't really matter. But generally speaking, systems in software, they shouldn't get much more complicated than a combination between what the module does plus how the modules collaborate with each other. Even if you are doing distributed architecture, like microservices, a microservice should ideally be a module that is completely encapsulated. So you should be able to test that module in isolation and say, okay, so this microservice, when it gets these kinds of events or these kinds of messages or these types of calls, this is what happens inside of it, and this is what it generates as a side effect, this event or these calls and so on. And so all systems in software, you can separate them into pieces that are isolated and collaboration between those pieces. And you can test both of these things. Only sometimes it's a bit harder due to multiple technologies getting involved. Like if the network is getting involved, you have more reasons to failure. If you have a database, more reasons to fail, and so on. But you don't get into the complex adaptive system world where the sum of the units is greater than the parts, because you end up with emerging behavior. The only time you get there is when every call to a unit actually fundamentally, or not fundamentally, changes the behavior of the unit. So if you have a software system in which you call, let's say microservices, because it's easier to imagine. You have 30 microservices, but every time you call a microservice, its behavior slightly changes. Then yes, you might end up with emergent behavior. But other than that, the behavior of software system should be largely deterministic. This changes when you introduce AI, right? Because AI is precisely the example of when you fit something in, the behavior might change. Or if you call it multiple times with the same input, it might give you different outputs. So in that case, I agree. But barring AI systems, which tend to be isolated anyway in most software systems, it's much more deterministic than that, and it helps us. So always think about systems in this way, and this is something that you can apply at different levels of scale. So you can think about microservices that get inputs and outputs, right? And collaborate with each other. You can also think about objects. You have an object, has a bunch of methods, gets inputs, you get outputs, but it also collaborates with other things. You can test its behavior in isolation, collaboration in isolation if you really want to. Is it always the perfect idea? Not necessarily, because then the tests get too coupled with the production code, which is why we prefer figuring out which are the behaviors in a unit. Ideally, it should be a module, right? In a module of your code. And what are the inputs you can pass in? What are the outputs you expect for different behaviors? Uberto Barbini, in unit testing, if your library allows for soft assertions, one macro assertion for test is usually a good rule. Khaled Suf, totally agree. One scenario per test is a better option, in my opinion. Agile author Tim Ottinger, I'm much more in the one action per test camp. If you have multiple assertions, they are different evidences of the same actions. Maybe it logs a failure and throws an exception and leaves the data unchanged. Maybe correct is more than one thing. And to me, this would be, I'm most in line with Tim Ottinger here. I think he's right. This is kind of how I'm thinking as well. Let's see. Yeah, Francois Bavai, what I was saying before. When this situation occurs, expect the method to group the assertions into one well-named assertion. Just because your testing framework doesn't have assert user is log doesn't mean you can't create it. It also ensures your multiple assertions only check one thing. Absolutely. I agree. And then another interesting comment by Mark Wren, probably should be measured in cost to identify root cause. Just been commenting out assertions to isolate the code under test for debugging. Multiple assertions can be a pain. Now, this is correct. Although, to me, this is, once again, a symptom of not writing the correct or the best message for diagnosis in the assert. So, and this is about it. This was the whole thread, actually the highlights from this thread, but I felt that this conversation was really interesting, and I know that many people are still struggling with tests, at least based on what I see in the test suites. So there are a few things that you might want to remember, and just a summary. Number one, see that your test is failing. So write it first, run it, and see what the failure message is. And make sure you take a few minutes to improve that message, because you will thank yourself 6 months or 1 year from now, and that test will fail. And you'll have to spend, maybe 10 minutes less figuring out what the hell is going on. So really, really good thing to do. It's a good investment. It's brief. It might require you to learn a bit about how to change the message in your assertion library, but it's really worth it. Second, name your tests properly. Name your tests with something that defines the behavior. It says the given when and then elements, and not only the test user. It doesn't tell me a lot. Test newly created users are valid. Slightly longer. Test names can be longer because they are quite easy to read when they fail. And the extended thing here would be if you figure out how to create a report that has all the test names separated by, as sentences, and maybe the assertion names also as inside the test names, so that you get a nice report on that gives you the list of behaviors and checks for your system. Then don't hesitate to create custom asserts. They are really useful. And try to separate tests. So when one thing changes in your production code, ideally few tests fail. The golden ideal would be only one test fails, but this is probably impossible to do. The one thing that we know we don't want, no more than 10 tests to fail, because it's more than 10 tests, something is really, really wrong in your test structure or in your code structure. And finally, think about the coupling between your tests and your production code, and try to reduce that coupling. There are a number of ways to do that. Removing duplication from tests, avoiding mocks, and testing behaviors rather than collaboration as much as possible. And basically checking the inputs and outputs, because if you can look at the inputs and outputs for a behavior, even though that behavior covers multiple classes or multiple objects, this allows you to refactor the code without changing the tests. Okay? You can reorganize parts of the code related to that behavior. For example, move from 3 classes into 1 class and so on, without changing too much in your test code. And this is something that's really, really useful. And also, one of my favorite things, this is something that I like to do often, is use data-driven tests as much as possible. I think data-driven tests are extremely helpful. And something like Spock framework is incredible, where you can have like tables of this is the input data, this is the output, or reading or generating inputs. These are things that are really, really useful for tests and can cover a multitude of scenarios. And just to leave you with something that's slightly more, let's say maybe more interesting, consider having your tests available in the production code as well. This is something I've been experimenting with, and I think it's really good to have it. So I'm working on an internal application, which is a web application that we'll use to manage a bunch of things. And I split it into modules. Each module is linked with a base URL. And for each base URL, you can call base URL /test. And that would actually run all the tests for that module in production. And by in production, it doesn't necessarily mean that it uses the production database, but it runs in the production environment. Now, if I were to deploy this for, let's say, general use, I would probably limit the calls to /test to specific logged in users, or to IPs, or somehow. I mean, I don't want anybody to be able to call /test. But I think the separation between test and production is really artificial, and it's something that happened due to historical reasons. we needed to separate test code from production code because it was difficult to do it in any other way. But this is also one of the reasons why we see testing or writing automated tests and writing production code as two separate things. Whereas in my opinion, and in the opinion of many people from adhering to extreme programming or software craft, you write tests in order to help you with the production code. So by having tests with the production code, this is something that I believe will help us get over this cultural block of, tests are separate from production. I don't like to write tests because I want to solve the problem. No, you actually solve the problem through writing tests. So that's it from me today. My voice is still not up to date, but not fully healed. I hope by next week it will be better and I'll be able to record some more videos so that we can catch up with many things that happened since the beginning of the year and that I wanted to comment, but I couldn't. There are many things that I'm interested in and that I can't wait to share with you. But for now, I hope you found this interesting. Leave us a comment. We love comments. Thank you kindly for the view. And until next time, remember to think, design, and work smart.